Hi everybody. So today we are going to look at a really nice way of evaluating some limits. And let me show you some stuff that we actually already know. For example, if I wanted to evaluate the limit as x approaches infinity of x plus 3 divided by maybe 2x minus 4, then we know that as x gets really big, this is a rational expression, and the degree of the top is the same as the degree of the bottom. So back in pre-calculus, we learned that the limit would approach the ratio of the coefficients, so it would be 1 divided by 2. And then in calculus, we learned that another way that we could evaluate these limits is that the highest power here is x to the first. So if I was to multiply the top by 1 over x to the first and the bottom by 1 over x to the first, then this would be equal to the limit as x approaches infinity of 1 plus 3 divided by x divided by 2 minus 4 divided by x. And now as x is approaching infinity, I can see that this is approaching 0 and this is approaching 0, which would get me that the limit is approaching 1/2. And all of that is totally fine and good. But what would happen if we had to evaluate something like, I'll call this example 2, the limit as x approaches infinity of the natural log of x divided by x. So there's some things here that are very similar. If you'll recall, the graph of the natural log looks something like this, which means that as x is approaching infinity, the natural log is also approaching infinity. In my limit, the denominator is x, and so that is also approaching infinity. So I have this limit that is of the form infinity divided by infinity, but my trick from above isn't going to necessarily work, since there isn't a power of x on the top that I could divide, that I could multiply by 1 over that power. This kind of places me puts me in a situation where I am stuck. So today what we're trying to do is be able to evaluate this kind of a limit. So the way that we're going to evaluate these limits is by using what is called L'Hopital's rule. And L'Hopital, if you're interested, was the first person to ever write a calculus book. So we have him to thank for all of this. So L'Hopital's rule is used for evaluating limits where the form is either 0 over 0 or infinity over infinity. And there's a lot of words here in L'Hopital's rule, and the words are important, but not as important as the concept. So we have two functions, f and g, and what's going to happen later is that we're going to be thinking about the limit as being a limit of f of x divided by g of x. And so our requirements are that they are differentiable on an open interval a to b that's containing the point c, and what we will see later is that x is going to be approaching the value of c, and so that's going to be the c that is in our definition, except possibly at c itself. And the second requirement is assume that g prime of x is not equal to 0 for all x in that same interval, except possibly at the point itself. And then lastly, if the limit of f of x divided by g of x as x approaches c produces the indeterminate form infinity 0 over 0 or infinity over infinity. Now, that's a lot of words. So if you're confused at this point, watch the next minute and a half and then go back and see if this makes a little bit more sense. What it says is that if we're looking at the limit as x approaches c of f of x divided by g of x, then that is going to be equal to the limit as x approaches c of f prime of x divided by g prime of x. And then, of course, provided that the limit on the right exists or is infinite. And we'll look at some examples, and all of this, I think, will make a lot more sense. But here's the key thing about L'Hopital's rule. If the limit is of the form 0 over 0 or infinity over infinity, then what L'Hopital's rule says is that you can simplify the limit by just taking the derivative of the top and dividing it by the derivative of the bottom. The derivative of the top and then divided by the derivative of the bottom.